Today we'll start the new lesson 3.6. It's about solving a system of linear equations. First part in this lesson is what is the meaning of solving a system of equations. First, when I say, guys, a system of equations, it's equation of what? What is this equation? When we have x and y, what represents this equation? It is a linear equation. It is an equation of a line. And this one is also an equation of a line. If I want to think about those two lines. If we draw those two lines in an orthonormal system, what will happen? Perhaps they will meet, perhaps they are parallel, perhaps they are coinciding. First, if I want to solve this system algebraically, so I can do it by substitution or by elimination. Now here I'm doing this system by substitution. If I take the first equation, all the time substitution, it's easy when the coefficient of x or y is 1. So here, since the coefficient of y, for example, is 1, so I can find y in terms of x or vice versa. But here I got y in terms of x. I replace it in the second equation. I got 2x plus 3, 7 minus x equal to 4. Then you solve and I got x. I got x and I replace it in the first or even in the second. You can replace it either in the first or in the second equation. And I got y is equal minus 10. What does it mean? If I want to think about this 17 minus 10 geometrically, what does it mean? It means if you draw those two lines, they will meet at the point 17 minus 10. It means that those two lines, they intersect. They have a point of intersection. So the solution of this system is 17 minus 10. So what is the meaning? I wrote that. If I draw those two lines, they will intercept at 17 minus 10. It means this is the point of intersection. But also, you can predict this result. You can predict the position. You cannot predict the result, but I can predict, I can analyze that those two lines they have a point of intersection. We can compare the slopes of the line. So if I write the first line in the slope-intercept form, it's y equal minus x plus 7. The second line and also slope-intercept form. If you look at those two slopes, since the slopes are not equal, it means that the lines are not parallel, because we know that if the slopes are equal, the lines are parallel. So I'm sure that those lines they should meet. So if you solve the system and if you didn't get one solution, it means there is something wrong with your work. You need to double check your calculation. Let's move to another example. This is another example. Also, I can first, what I did here first, I was predicting the answer, then I solved it. If you write the first equation in the slope-intercept form, it will be y is equal minus 2x over 3 plus 1, because here you take 2x to the other side, will be minus 2x, then over 3 over 3. Here, if you write in the slope-intercept form, you will get this answer. If you look at those two lines, they have the same slope, and that's not enough. If they have the same slope, it means they are parallel. But they should have same slope and different y-intercept to say parallel. It's not just enough to say same slope. They have the same slope. I look at B, at the y-intercept. If it's the same, it doesn't mean that they are parallel. It means they are coinciding, they are overlapping. So those two lines, they have same slope and same y-intercept. What does it mean? As it's the same line. Look at those two lines, they are the same. So it means they are coinciding or overlapping. It means I have infinite solution. But how can I find this result? By calculation. I did it here by elimination. I replaced the first one, multiplied by minus 3. How do we eliminate? You look at, you decide. For example, I want to eliminate x. So those two should be opposite. By what should I multiply 2 to become opposite of 6? By minus 3. So I multiply all the first equation by minus 3, and then I add those two equations. I will get 0 equal to 0. 0 equal to 0, it's all the time true. What does it mean? I have infinite many solutions. What does it mean? If I want graphically to analyze it, that those two lines, they overlap, if I will draw it. So I can predict also the answer of the system by just looking at the slope and the y-intercept. Now, what's gonna happen if the slopes are the same, but they have different y-intercept? This is the case of parallel. So be careful. Same slope, same y-intercept, they are coinciding. Same slope, different y-intercept, they are parallel. So if I move now to this example here, you can compare those two lines. I fixed it, I wrote it in the slope-intercept form. They have same slope, different y-intercept. It means the lines are parallel. It means the system doesn't have any solution. It means if I draw those lines, they will not meet. There is no intersection. And if I do it algebraically, I did it by elimination, by multiplying by -2, I will get 0 equal -20. Is it a true result? It's wrong. It's not a true result. What does it mean? So it's impossible. I have no solution. It means the line doesn't intersect because the lines are parallel. Let's move to another example about, it's an example, but one of the coefficient is unknown. So I have here for x minus y equal to 1, I have 3x plus my is equal to 2. And the question is to discuss, according to the value of m, the number of solution of the system of equations. When I say number of solution, the best way is to think about to compare the slope and the y-intercept. So what I did, I wrote the two equations, the slope-intercept for, and now I compare. You will tell me, Miss, but should I write here m not equal to 0? No, I cannot. No, I need to write that. Why? Because this is not the original given. If it was given like this, sure, you should write m not equal to 0. But the equation was given like this. So if m is 0, it works. M is 0, I don't have y, so I will have x is equal -2/3. I replace by x here, I will get the answer of y. So if this equation was given as original equation, yes, I should write m not equal to 0. If it's like this here, no, I shouldn't write it here because m can be 0 and it will give me exactly one solution. So I start to compare. If I want to have exactly one solution, it means the slopes shouldn't be the same. So 4 cannot be equal to -3 over m. So m will be not equal to -3 over 4. So if m is not equal to -3 over 4, it means I have exactly one solution. Now, the case 2, no solution. What does it mean, no solution? No solution, it means the lines are parallel. It means they should have same slope but different y-intercept. If the slopes are the same, it means I have -3m equal to 4, m is equal -3 over 4, and I need to have m not equal to -2. So should I write m not equal to -2? Don't need to write that, because once m is equal -3 over 4, m cannot be another value. So this one I don't need to write it. So it's enough to say for m equal -3 over 4, I have no solutions, because in this case, sure b is not the same, sure y-intercept is not the same, because y-intercept is the same if m is equal -2, and the lines will be parallel and they will not meet, so there is no solution. Can I have many solutions here? It's impossible. Why? Because if I have many solutions, I should have the same slope and I should have the same y-intercept. It means, can I have in the same time m equal to -3 over 4 and m equal to -2? No, I cannot have two different values for m in the same time. So can I have the case no solution, many solutions, sorry? No, I cannot have this case. So I can just have in this system the case of one solution or no solution. One more example, exactly the same. I have two equations. I change it to the slope-intercept form. It's the best. As I said, no need to write p not equal to 1 or p not equal to 0, because if p is equal to 1, excellent. I have x is equal -, have its a solution. I will replace it here and I will have y. And if p is equal to 0, I will get y equal -2/3, and it's another solution. Exactly the same. If I want to have one solution, the slope should be not equal. So I will solve -2 over p -1 not equal to -p/3. It's a quadratic equation. We know how to solve it from the preceding chapters. So using the calculator or delta, and this one here, I should have p not equal to 3 and p not equal to -2. Now, can I have no solution here? What does mean no solution? It means that the lines are parallel. The lines are parallel. It means I have equal slope. It means p should be equal to 3 or p is equal to -2. And the same time, I need to check that the y-intercept can't be equal for those two values. So I should write 1 over p minus 1 not equal to 2 over 3. If I solve this one, I will get p not equal to 5 over 2. This is true because I just said that I need to p to be equal to 3 or p is equal to minus 2. If p is equal to 3 or p is equal minus 2, I have the same slope, but I will not have the same y-intercept. The y-intercept is the same for p is equal to 5 over 2. So it means that I can have the case no solution, and the case no solution, it's for p is equal to 3 or p is equal minus 2. Exactly the same like the preceding example. Can I have, sorry, the case of infinite solution? To have infinite solution, I should have same y-intercept and same slope. To have the same slope, I can have one of those two values, and to have the same y-intercept, p should be equal to 5 over 2. Can I have in the same time p equal to 3 and 5 over 2, or p is equal to minus 2 and 5 over 2? No, I cannot have it. So it means infinite solution doesn't exist. I don't have the case. So I just have the case exactly one solution for p is not equal to 3 and p not equal to minus 2. And I have the case of no solution for p is equal to 3 or p is equal to minus 2. If one of those values, p3 or p minus 2, gives me the same y-intercept, it means I'm in the case of infinite solution because the line will be the same. But here it doesn't work infinite solution because they don't give me the same value of. I hope you got this part. I still have two different parts. I will record two other videos for the remaining parts. Don't forget to like, subscribe, and share. And hope you got it and you don't have any issue with